Hello, everyone. Welcome to Sleep Space. Tonight, we'll talk about something that touches every moment of your life, something so familiar that you rarely question it. And yet, it's one of the deepest mysteries in all of science and philosophy. What is time, really? As you settle in, let your mind ease into the question. What exactly is this thing we call time? You see the clock tick, you feel days pass, you age. Memories form and fade, but is time something out there, something that exists independently of us? Or is it something we invented, something the mind uses to make sense of change? At first glance, time feels obvious. It's what keeps everything from happening at once. We measure it with watches and calendars. Seconds become minutes, minutes become hours, and the hours shape your days, your life, your story. But what are you actually measuring? Is time flowing like a river? Is it a sequence of events? Is it just entropy increasing? And if so, why does it only go in one direction? Let's start with how we usually experience time as a line. There's the past, the present, and the future. The past is fixed. The present is what's happening right now, and the future hasn't happened yet. This view of time feels natural, but it's not necessarily what the universe believes. In fact, the deeper physicists look into the structure of reality, the more slippery time becomes. One of the biggest breakthroughs in our understanding of time came with Einstein. In the early 20th century, he rewrote the rules with his theory of relativity. Before him, time was thought to be absolute. Newton said time ticks the same for everyone everywhere. But Einstein showed that time is not absolute at all. Time is relative. What does that mean? It means time doesn't pass at the same rate for everyone. If you're moving very fast, time actually slows down for you compared to someone at rest. This is not just a theory, it's been confirmed by experiments. Astronauts who spend long periods in space, where they move at high speeds, actually age slightly less than people on Earth. Their clocks tick more slowly. So already we see time is not some fixed universal river flowing steadily. It's elastic. It bends and stretches depending on motion and gravity. That's right. Gravity also affects time. The stronger the gravitational field you're in, the slower time moves. If you lived near a black hole, your seconds would stretch out longer than someone far away from it. This discovery forced scientists to stop thinking of time as something separate from space. Instead, they now speak of space-time, a four-dimensional fabric that combines space and time into a single entity. Objects don't just move through space, they move through space-time, and the way they move depends on their mass, velocity, and the curvature of the universe around them. But here's something strange. Einstein's equations don't require time to move forward. They work just as well in reverse. In fact, many of the deepest equations in physics are time symmetric. They don't care whether time is flowing forward or backward. Yet, your experience is very one-sided. You remember the past, not the future. You age, not de-age. You drop a glass and it shatters. You never see the shards jump back together. Why does time only go one way for you, even though the laws of physics allow it to go both ways? One explanation is entropy. The second law of thermodynamics says that in a closed system, disorder always increases over time. A neat room becomes messy. A hot cup of coffee cools down. Shattered glass stays shattered. This direction from order to disorder is often called the arrow of time. Entropy gives us a direction. It tells us which way is forward, but that just shifts the question. Why did the universe start in such a low entropy, highly ordered state? Why was everything so finely tuned at the beginning? The early universe, right after the Big Bang, was a state of incredibly low entropy. The energy was hot and evenly distributed, which may seem chaotic, but in terms of entropy, it was extremely organized. And from that order came the rise of stars, galaxies, and life. The arrow of time, it seems, began at the Big Bang, but no one knows exactly why it started that way. So maybe time isn't fundamental after all. Maybe it emerges from other properties of the universe, like entropy, the expansion of space, or the structure of consciousness. Some physicists argue that time is not a basic ingredient of reality. Instead, it's something that arises from deeper laws we don't yet fully understand. Others take it even further. There's a growing school of thought that says time might not exist at all, not in the way you think. Consider the block universe theory. It suggests that past, present, and future all exist simultaneously, like frames in a film reel. You feel like you're moving through time, but all the moments are already there. You're just experiencing them one at a time. From this view, the flow of time is an illusion. You don't move through time any more than you move through a book you've already written. Every chapter exists, you're just reading one page at a time. And if that's true, then what is the present? Why does now feel special? This question touches on both physics and consciousness. Physically, there's no universal now. Two observers moving at different speeds won't agree on what's happening at the same time. In Einstein's world, simultaneity is relative, so the idea of one single shared present breaks down. What's now for you might already be the past, or not yet the future for someone else. That's a wild thought. It means that what you call the present is a construct, something your brain assembles based on sensory input and memory. Your sense of time is deeply tied to your perception of change, movement, and cause and effect. Without memory, you wouldn't have a sense of the past. Without anticipation, the future wouldn't exist for you either. Some neuroscientists believe your consciousness may actually be what creates time for you. The present moment might be the width of a psychological window, perhaps a few seconds long. Everything before that is memory. Everything after is imagination. So if the universe doesn't single out a now, and physics doesn't require a flowing timeline, and your brain assembles time from perception and memory, what is time, really? Maybe time is the way your consciousness interacts with change. Maybe it's a structure the mind uses to sequence events and make sense of cause and effect. Or maybe time is a side effect of entropy increasing, giving structure to your experience, but not truly existing on its own. There are also some theories in quantum mechanics that complicate time even further. In quantum physics, particles exist in superpositions, states where they're not in one position or another, but in both simultaneously, until they are observed. But when is that observation? When does the state collapse into something real? What time is it in quantum terms before something is measured? In some interpretations, like the timeless Wheeler-DeWitt equation, time doesn't even appear in the fundamental equations of the universe. It only shows up when you zoom out and look at large systems with many particles. From the quantum point of view, the universe just is a frozen possibility cloud where time is not fundamental at all. And yet, here you are, experiencing a moment, watching this video, feeling the passage of time. You can't escape it, but perhaps the experience of time is not what you think it is. As you begin to relax and let these questions settle into your mind, think about what it would mean if time wasn't something outside of you, but something your consciousness was generating from within. What would it mean if your memories, your identity, your plans, all lived within this construct? Not out there in the stars, but in here, in awareness. And if time is not absolute, if it bends and warps and maybe doesn't exist at all in the way you believe, what else might not be what it seems? Tonight, as you fall asleep, imagine letting go of time. Imagine floating outside the stream. No past, no future. Just this one moment, stretched like a gentle wave across the ocean of now. To understand time more deeply, we have to step away from our ordinary experience and start asking questions that don't have easy answers. One of the most important is this: is time something we discover in the universe, or something we invent to make sense of it? Let's look again at the block universe model. In this idea, the universe isn't evolving through time. Instead, all of time already exists. Every moment, your birth, your present moment, your distant future, is like a location in space. In a block universe, time is more like geography than a river. You don't move through it. You exist in it. If this is true, the flow of time is an illusion. We experience one slice at a time, just like reading a sentence on a page, but the whole book is already written. This sounds strange, almost unsettling, but mathematically, this is what Einstein's theory suggests. Space-time is a four-dimensional object, and all the events in it are equally real. You just experience them sequentially because that's how your brain is wired. This also raises a powerful question. If past and future both exist, are they just as real as the present? When you think of a memory, you're accessing something you label as gone. But in the block universe, that memory isn't just a mental recording, it's a still existing region of space-time. Likewise, the future isn't something that hasn't happened yet. It's a place in the block you haven't experienced. This doesn't mean you can walk into the future like stepping into another room, because your consciousness is bound to one frame at a time. But some physicists think this is simply a limitation of how consciousness moves through space-time, not a reflection of time's true nature. Now let's step into a different direction: quantum physics. In quantum mechanics, reality behaves in ways that seem incompatible with the smooth, continuous flow of classical time. Instead of a universe that unfolds predictably, quantum particles exist in states of probability. They don't take on definite positions or velocities until they are observed or measured. This leads to one of the strangest questions in physics. When does something become real? If a particle is in a superposition of many possible states until it's measured, then what is time doing in between? Is the particle evolving in time while it's in superposition? Or is time itself undefined until something becomes definite? One interpretation, called the Copenhagen interpretation, says that time exists continuously, but the outcomes are only realized when measurements are made. But others, like the timeless interpretations, argue that time isn't fundamental at all. In fact, in some of the deepest equations of quantum gravity, such as the Wheeler-DeWitt equation, there is no time variable at all. This suggests that the universe, at its most fundamental level, might be timeless. Time appears only as an emergent property, rising out of the collective behavior of particles or the limitations of our own perception. In this view, what we call time is not a real, flowing force, but a statistical pattern, a projection, or a psychological illusion. Still, our experience of time is relentless. Why does that experience feel so deeply real if the universe might not have time built into it? Neuroscience offers a clue. Studies of the brain suggest that our sense of time arises from the way we process change and causality. You recognize that something has changed from one state to another, and your brain encodes that as time passing. But if nothing changes, if no memory forms, your sense of time collapses. This is why time can feel like it speeds up or slows down depending on your mental state. When you're deeply engaged or emotionally stimulated, your brain creates more memories, making the moment feel long and rich. When you're distracted or stuck in routine, fewer memories are formed, and time feels like it vanishes. A day of travel seems long while it's happening, but looking back, it feels short. A year of repetition feels like a blur. So maybe time is not just what the universe is doing, it's also what your brain is doing. You don't experience time itself, you experience changes in perception, changes in memory, and changes in expectation. Your awareness stitches those together into a timeline. But if you could step outside your awareness, what would you see? This leads us to another concept: emergent time. In modern physics, there's a growing idea that time is not fundamental, but something that emerges from more basic rules. Rules about how information and entropy behave. Just like temperature isn't a property of a single particle, but of many particles moving together, time might be a property that only makes sense when large numbers of things interact. In the same way that a crowd forms waves or a gas has pressure, time might only exist when there's enough complexity to give it meaning. A single particle might be timeless. A universe full of stars and observers might create time. This connects to ideas in quantum gravity, where physicists are trying to combine general relativity and quantum mechanics into one theory. These attempts often lead to models where space and time are not primary. They emerge from something more fundamental, perhaps from networks of information or from quantum entanglement patterns. Think of this like a hologram. A two-dimensional pattern of information can create the illusion of a three-dimensional object. Some scientists believe space-time itself may be a holographic projection from a deeper, timeless structure. But what would that mean? If time is not fundamental, if it's an emergent property, then the question, what is time, becomes something like asking, what is a rainbow? A rainbow exists, you see it, but it's not an object floating in the sky. It's the result of light interacting with water droplets and your eyes. Time, in the same way, may be a result of deeper interactions between particles, laws, and minds. Let's go further. Time not only governs how we experience change, but also how we define cause and effect. Something happens, and then something else happens because of it. That's cause and effect. But if time is not fundamental, is cause and effect fundamental either? In some interpretations of quantum physics, events aren't ordered in a clear sequence. Instead, they seem to influence each other in ways that don't respect classical time. In quantum entanglement, two particles can become linked in such a way that the state of one instantly affects the other, no matter how far apart they are. This happens faster than light can travel, but does it happen in time, or does it transcend time? Some researchers suggest that entanglement doesn't operate within time as we know it, but that entanglement might actually be what gives rise to time. That's a bold claim. It means that time might not be the stage on which the universe plays out. Time might be a character in the story, created by the interactions of other characters. And then there's retrocausality, a fringe but intriguing idea that the future might influence the past. Some quantum experiments suggest that choices made in the present can affect the outcome of events that seem to have already happened. If that's true, the direction of time isn't just forward, it's a loop. The future shapes the past just as much as the past shapes the future. This brings us back to consciousness. Your awareness exists only in the present, but that present is a thin slice of something larger, a timeline you can't fully see. Some philosophers propose that consciousness itself might be the engine that makes time appear to flow. Without a conscious observer, the universe might not have time at all. That idea sounds strange, but consider this. In your dreams, time behaves differently. Entire hours can pass in a few seconds. Sometimes you jump from one scene to another with no sense of how you got there. Time bends, breaks, pauses. But while you're dreaming, it still feels real. So what if waking time is just another layer of that illusion? More consistent, more structured, but still built from the same mental ingredients. If your brain constructs the sense of time, and physics suggests that time might not be fundamental, then your personal experience of time could be a hallucination that aligns with your brain's predictions. Let's look at how time is used in other areas of science. In biology, circadian rhythms regulate your sense of time. These rhythms are controlled by biological clocks in your brain and cells, influenced by light, hormones, and behavior. They don't measure time the way a clock does. Instead, they respond to cycles. Sunlight rises and falls. Body temperature fluctuates. Hormones increase and decrease. Your body reads these signals and builds a map of when you are. But even this internal time is subjective. Jet lag disrupts it, aging distorts it. Trauma can freeze your perception of time, while joy can stretch it. So time is not only a physical idea, but a deeply biological one. It's something your body feels, your brain constructs, and your consciousness navigates. What's most fascinating is that every culture, every civilization, has had a different relationship with time. Ancient Greeks saw time as cyclical. The Mayans believed in repeating ages. Eastern philosophies often describe time as an illusion, Maya. Western science embraced linear, mechanical time. And now, modern physics is circling back to the idea that time might not be linear or fundamental after all. So what is time? Is it a dimension, a force, an illusion, a rhythm, an emergent property, or something else entirely? Right now, no one knows for sure. But the more you ask this question, the more time begins to dissolve into a mystery, one that lives at the edge of physics, philosophy, biology, and consciousness. If time isn't fundamental, and might instead emerge from deeper principles, we're left with a challenging realization. The very idea of before and after may not be woven into the fabric of reality. They may be stitched into your perception, useful, powerful, but ultimately incomplete. To explore that more deeply, let's shift focus to how time appears across different scales of the universe. Time feels constant in everyday life, but what happens when you zoom in to the smallest scales or zoom out to the vastest stretches of the cosmos? At the Planck scale, the tiniest possible level where space and time may no longer behave continuously, the smooth flow of time may break down completely. This is where quantum fluctuations dominate. Here, space-time might not be a continuous surface at all, but something granular. Like pixels in a digital image, time may be composed of tiny, indivisible units. Planck time being the smallest measurable tick. Planck time is unimaginably brief. About 539 Planck times 10^44 seconds. To get a sense of that scale, imagine slicing 1 second into so many parts that the number of slices is greater than the number of atoms in the known universe. That's 1 unit of Planck time, If time is indeed discrete rather than continuous, then the flow we experience could be like frames in a movie, a rapid succession of static states that create the illusion of motion. This also implies that between two moments, there may be no such thing as half a moment. There's only the next. Just like a digital clock clicks from one number to the next, reality might shift from state to state with no in-between. At the other end of the scale, time also behaves differently in cosmology. Our universe is expanding, and that expansion affects how time flows on a cosmic scale. Distant galaxies are moving away from us, not because they are flying through space, but because space itself is stretching. As the universe expands, the light from those galaxies gets redshifted, its wavelength stretched out, slowing the arrival of each photon. This creates a form of time dilation across the universe. This means that if you were to look at a distant object in space, you're not just looking across space, you're looking back in time. The farther away you look, the older the light you're receiving. Some of the light you see from far-off galaxies was emitted billions of years ago, long before Earth even existed. In a very real way, astronomy is a form of time travel. Telescopes let you see into the deep past. And yet, the paradox emerges. If the universe is expanding and evolving, what does that mean for time itself? Is it stretching too? Is the present a moving surface across space-time, or does it exist at all? Some models suggest that the entire four-dimensional block of space-time already exists, but it's not static. Instead, the geometry of space-time itself evolves as the universe expands. This evolving block model keeps the idea of a growing now, where new slices of time are constantly added to the universe. Unlike the static block universe, this one still allows for a sense of unfolding, but it raises hard questions about what causes that growth. What determines which moment comes next? This brings us into the realm of time's directionality. Why does time seem to move forward? We talked about entropy, but there are other ideas too. One is based on quantum decoherence. When quantum particles interact with an environment, their superpositions seem to collapse, not because of observation, but because the environment causes them to lose coherence. This process creates a kind of record in the universe, an imprint that can't be undone. Decoherence may be responsible for why the quantum world, which is time-symmetric, gives rise to a classical world with a direction. Think of it like this. When a wave of possibility collapses into a single event, that event becomes embedded in the environment through heat, motion, and information. It becomes irreversible. That's the arrow. Once you observe something, you can't unobserve it. The system moves forward and the history builds. If decoherence defines the arrow of time, then the past is a set of fixed records, events that have been imprinted into the universe. The future is still a wave of potential, uncollapsed, undecided. Time then becomes a process of converting potential into memory. You move through time by reducing uncertainty. But here again, time may not be doing the moving. Your experience might be the movement, not time itself. What if consciousness is the mechanism that navigates space-time, like a light sweeping across film frames, activating one after the other? This is where physics meets the mystery of subjective experience. Why does it feel like the present moment is constantly updating? What is it that creates the sensation of now? Why does it feel like you're moving forward? Some theories suggest that now isn't a point in time, but a region, a span of psychological presence. Brain studies show that we live in a window that stretches a few seconds wide. This is called the specious present. Everything you experience as now is really a composite of sensory input, memory buffering, and anticipation. Your brain stitches these into a seamless flow, even though delays exist between sensation and perception. For instance, when you hear a sound and see a flash at the same time, those signals arrive at your brain at different speeds, yet you experience them as simultaneous. Your brain smooths over the lag by creating a narrative, by bending time to fit your expectations. So again, time is not just physical, it's psychological. You're not a passive passenger in time, you're an active participant, shaping your timeline as you go. Let's consider another radical idea: time as information. In this view, time isn't a dimension or a direction, but a way of organizing data. The universe is full of information: positions of particles, quantum states, gravitational fields. When information is lost or scrambled, as in entropy, time seems to pass. When information is preserved or reversed, time seems to stop or reverse. This view makes sense in black holes. According to classical physics, anything that falls into a black hole is lost forever. But quantum physics says information can't be destroyed. This leads to the black hole information paradox, where time and information collide. Some physicists believe that the information isn't lost but encoded on the event horizon, a two-dimensional surface surrounding the black hole. This leads to the holographic principle, which suggests that everything inside a region of space, including its time evolution, can be described by data on the surface. Time, in this case, may be a projection from this information. If that's true, then perhaps the flow of time is just the rearrangement of data. The universe might be a giant quantum computer running a vast simulation, where time is simply the processing order of events. Of course, this doesn't mean the universe is a literal computer, but it implies that what you think of as time might be the algorithm used by the universe to organize its evolution. In this model, what we call the future is not a place we travel to, it's a calculation the universe hasn't yet completed. The past is the data already stored. The present is the current operation. It's a radical departure from classical time, but it solves some paradoxes. It allows for reversibility. It fits with quantum entanglement. And it might explain why time appears to have a direction, even if the laws don't. But where does this leave you? You live in a body. You feel hunger and joy. You remember birthdays and regret missed chances. Time for you is more than a measurement. It's a container for emotion, identity, and experience. If time is an illusion, what does that mean for everything you are? Maybe it means your memories are just as real as your actions. Maybe the future you imagine already exists in some form, waiting to be collapsed into experience. Maybe your consciousness, which rides the wave of now, is more fundamental than time itself. Some thinkers, both in science and philosophy, have proposed that consciousness and time are inseparable. Without awareness, time has no meaning. Without time, awareness has no structure. Each gives the other shape. In this view, time is the mind's mirror. It reflects not the ticking of a clock, but the unfolding of attention. Where you place it, how you follow it, and how you construct the flow of events around it. And so we return to the mystery. What is time, really? Is it a map, a rhythm, a feature of consciousness, a glitch in your perception, a curve in space-time, or a process of encoding and decoding information? None of the current theories can explain all the data. Physics has models. Neuroscience has patterns. Philosophy has ideas, but no single answer satisfies every domain. Maybe time is something we haven't discovered yet, something that will require a new kind of science or a new kind of awareness to fully grasp. If time is not a thing we move through, but instead a structure our minds help create, then everything you know about reality, past, present, future, might be more like a narrative than a physical path. Time might not be a track you walk, but a story your consciousness is telling moment by moment. Let's ask a slightly different question. Not just what is time, but what would the universe look like without it? To begin answering that, imagine freezing everything, not slowing it down, but truly pausing the universe. No atoms vibrating, no particles in motion, no thoughts, no light, no sound. Just stillness. Would time still exist? In a timeless universe, there would be no change, no events, no measurements. All physical processes would be suspended. From the perspective of physics, if absolutely nothing changes, then time doesn't pass. Time is not an object or substance. It is a relationship between events. Without events, the relationship vanishes. So perhaps time is only real when there's change, and that invites a profound question. Is change more fundamental than time? Is time just our way of noticing change? Heraclitus, the ancient Greek philosopher, once said, "All is flux." He believed the core of reality was change itself, that even when you look at something that seems still, a rock, a mountain, a planet, it is always in transformation. It's just changing more slowly than your senses can detect. Modern physics supports this. Even seemingly static matter is teeming with activity at the quantum level. Particles pop in and out of virtual states. Fields fluctuate. Atoms vibrate. Change is constant. But does change cause time, or does time allow change to occur? This leads us into the heart of a long-standing philosophical debate. Is time fundamental or emergent? If time is fundamental, it means that it exists at the most basic level of reality. It is built into the structure of the universe and cannot be reduced to anything else. Like space, charge, or mass, it simply is. If it's emergent, that means time is not a building block, but a consequence, a product of more primary elements interacting. In this view, change comes first. Time arises as a way to make sense of sequences of change. Emergent time explains some strange phenomena we see in physics. For example, in entangled systems, where two particles are linked in such a way that they share information instantly across vast distances, the connection appears to occur without reference to time at all. It seems instantaneous, not because it's faster than light, but because it may not happen in time as we experience it. If interactions can exist outside of time, then time may not be necessary to describe the deepest layers of reality. What you experience as a timeline could be the visible edge of a much more complex structure. A structure not built on clocks, but on relationships. Think of time like temperature. Temperature isn't a property of one particle. You can't assign a temperature to a single molecule. It only becomes meaningful when many particles interact. In the same way, time may not be real for isolated events. It only emerges when systems become complex enough to display irreversible behavior. And what makes behavior irreversible? Often, it's information loss. Consider a glass shattering on the floor. The atoms are still there, but the specific pattern that made it a glass is gone. You could never reconstruct it perfectly from the shards. This is entropy in action. Information has been scrambled. You remember the intact glass because your brain stored that state. You experience the shards as the future because they are the result of a transformation with lost information. From this perspective, time's arrow is tied to your brain's inability to reverse entropy. You can't remember the future not because it doesn't exist, but because your memories don't run in that direction. And here's where the human mind becomes central. If time is not universal, then your experience of it may be one of countless possible versions. Other creatures, bats, whales, insects, process time differently. Their sensory windows are tuned to different rhythms. A fly might perceive events in slow motion compared to you. A deep-sea creature might navigate a world with almost no light cycles, where time feels more fluid or abstract. This diversity suggests that time perception is biologically constructed. It's built into the machinery of your nervous system. Your heartbeat, your breath, your brain waves all generate rhythmic cycles that anchor your sense of continuity. Disrupt those rhythms, and your experience of time changes. This is seen in states of altered consciousness. Under psychedelics, meditation, trauma, or extreme boredom, people report dramatic shifts in time. Minutes stretch into hours. Hours disappear into seconds. Some report entering timeless voids. Others feel trapped in loops. These aren't hallucinations. They are your brain revealing its role in time perception. It creates time just as it creates color, sound, and selfhood. When its filters change, so does the world. This has profound implications. It means that time is not just something you move through, it's something you actively generate. And if you generate it, you can influence how it feels. This is why practices like mindfulness and meditation often bring a sense of timelessness. By stepping out of habitual thoughts and judgments, the brain stops stitching events into a narrative. You rest in presence, time loosens its grip. Even language reinforces time as narrative. We say we spend time, we lose time, we save it, waste it, run out of it. These are all metaphors of a resource, not a dimension. But what if these metaphors are misleading? What if time isn't something to manage, but something to witness? This brings us to the philosophical tradition of presentism versus eternalism. Presentism holds that only the present moment exists. The past is gone. The future has not yet come. The present is all that's real. Eternalism, by contrast, holds that past, present, and future all exist equally. The future is not created by the present. It already exists. You just haven't experienced it yet. Einstein leaned toward eternalism. In a letter to a friend's family after the friend's death, he wrote, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. If that's true, then time is not flowing. You are, but how does that idea affect your sense of agency? If the future already exists, does that mean your choices are predetermined? Is free will an illusion?" This is a deep question, and there's no consensus. Some argue that free will is compatible with eternalism because consciousness still experiences each choice moment by moment. Others argue that if all moments exist, there is no real choosing, only unfolding. Quantum mechanics complicates the picture. In interpretations like the many worlds theory, every possible outcome of a quantum event actually happens in a branching multiverse. In this view, time is not a single path, but an ever-splitting tree. Your experience of making a choice is real, but all other possible choices are also real, playing out in parallel. This leads to a radical notion. The universe may be a space of possibilities, and time is the process of exploring them. You don't just travel through time, you carve a path through a sea of potential. Each decision, each action, defines your trajectory through an infinite landscape. In this model, time is not a background, but a creative act. So again, we return to the mystery. What is time? Is it change, memory, entropy, perception, geometry, information, or possibility? Each of these ideas captures part of the picture, but none captures all of it. And that might be the point. Time may not be a single thing, but a multi-layered phenomenon. Part physics, part biology, part consciousness. You feel its pull. You measure its passing. You mark your life by its milestones. Yet the more closely you examine it, the less real it becomes. What's left is not an answer, but an invitation. To observe more carefully, to reflect more deeply, and to recognize that even the most familiar experiences are full of mystery. Time may be the greatest illusion of all, but it is also the canvas on which your entire life is painted. Time might be everywhere in your life, but it's nowhere to be found in the fundamental structure of the equations that govern the universe. If time is so essential to how we live, why is it missing from the deepest layers of reality? Let's look at an equation that puzzles many physicists: the Wheeler-DeWitt equation. It's one of the few attempts to unite general relativity with quantum mechanics, two of the most successful yet incompatible theories in physics. This equation aims to describe the quantum state of the entire universe. And yet, there's one thing missing from it: time. There is no t in the equation. It doesn't describe how something changes in time, because time isn't built into it. The Wheeler-DeWitt equation is static. It describes a frozen universe, a total configuration of everything that exists, with no temporal evolution at all. So where does the sense of time come from? One idea is that time emerges from correlations between parts of the universe. You may not be able to say that the universe as a whole is in time, but you can say that some parts of it are changing relative to others. It's those internal correlations that give rise to something we interpret as the passage of time. Imagine being inside a giant clock, but you can't see the hands. Instead, you observe that every time one gear turns twice, another gear turns once. You build a model of time based on these relative movements. You don't need an external stopwatch. You build your concept of time from how things relate to each other. This is known as relational time, and it's a shift from the idea of time as an independent dimension. In relational time, clocks don't measure time, they create it. And that applies to everything, even your mind. Your awareness is not anchored to a universal timeline. It's anchored to a changing sequence of mental states. You feel the passage of time not because time is flowing, but because your experience is updating. If time is relational, then perhaps it doesn't exist out there at all. Maybe time is not a feature of the world, but a feature of your model of the world. To understand how deep this goes, consider Julian Barber's theory of timeless physics. Barber suggests that the universe is made up of an infinite collection of nows, discrete, self-contained moments, each with its own configuration of matter and energy. These moments don't flow or change, they just are. Your experience of movement through time is, in this view, a kind of illusion caused by the order in which your brain interprets these static configurations. The movie of your life is actually a collection of snapshots, like frames in a cosmic slide projector. Consciousness makes the slideshow feel continuous. Barber compares this to pages in a book. All the pages exist at once, but your mind reads them in a sequence. That's what creates a story. But nothing about the book itself is changing. It's your position that moves, your awareness that progresses. Now ask yourself this: if every moment already exists, and your consciousness is simply selecting one frame after another, is there any real difference between memory and destiny? Is the future just a page you haven't read yet? This leads to another mystery. Is the flow of time an illusion produced by memory? Memory anchors you. It lets you construct a sense of continuity. Without it, each moment would be isolated, timeless. People with amnesia often report a strange absence of time. They live in a kind of eternal present, unable to trace their existence backward. That makes memory a key component in the creation of time. Not physical clocks, not celestial orbits, but the biological recording of experience. And it's not just human memory. The universe itself seems to have a kind of memory encoded in physical structures. Tree rings record seasons. Rocks hold the marks of geological ages. DNA carries a history of evolution. Entropy accumulates in patterns. Everywhere you look, you find layers of evidence, each one pointing to a past that once was, shaping the now. But how does the universe store its own past? It does it through irreversible processes. When energy is used, it dissipates. When particles interact, they leave traces. These records cannot be perfectly undone. That's what creates the illusion of a moving present. It's not that the past is gone, it's that you can't fully go back. But why not? Physically, the laws of nature allow backward motion. Newton's laws are time symmetric. Maxwell's equations don't care if time goes forward or back. Even quantum mechanics, with all its strangeness, respects time reversal symmetry. Yet, the world you experience only goes one way. One explanation, again, is entropy. The universe started in a state of extremely low entropy. That initial condition, whatever its origin, created the arrow of time. But that doesn't explain why the universe started that way. No one knows. It remains one of the deepest mysteries in cosmology. Why did the Big Bang produce such an ordered state? Why didn't it begin in chaos? Some suggest that entropy is only increasing from your perspective, that time's arrow might look different from other vantage points in the universe. There may even be regions where entropy runs in reverse. If so, beings in that region would experience time backwards compared to you. But to them, it would feel perfectly normal. Now let's consider a provocative question. Could the past still exist right now? In the block universe, the answer is yes. The past is not gone. It's just a different location in space-time. From that perspective, your birth is just as real as this very moment. You just aren't experiencing it currently. But could your consciousness ever return to it? Some philosophers and physicists think the answer might be yes, if time is just a coordinate and if your awareness is not fixed. There's no known physical mechanism for this, but in theory, if your consciousness could move through space-time the way light does through space, perhaps you could visit earlier pages in your story. Even the idea of reincarnation takes on a different meaning here. What if rebirth is not about cycling forward into a new body, but cycling back into a prior state of the universe? What if déjà vu is not memory from a past life, but echoes from a different region of the block? This may sound speculative, but it's no less strange than time dilation, entanglement, or quantum timelessness. The point is this: your model of time may be far less objective than you think. Consider time loops, a concept found in both science fiction and actual physics. In general relativity, there are solutions to the equations that allow for closed time-like curves. These are paths through space-time that loop back on themselves, creating theoretical time machines. In one such model, called the Gödel metric, the rotation of the universe causes time to bend in such a way that you could, in theory, return to your own past. There's no evidence that our universe works like this, but the equations allow it. Of course, this leads to paradoxes. What happens if you travel back and change your own past? Could you stop your grandparents from meeting? The infamous grandfather paradox shows the logical trouble with backward time travel. One proposed solution is the Novikov self-consistency principle, which says that events along a closed time curve must be self-consistent. You can't change the past because anything you do there was always part of the timeline. You have free will, but it's already accounted for. If that sounds like fate, you're not alone. But in a deterministic block universe, fate and choice might be two sides of the same coin. You choose, but the structure of space-time already contains your choices. And yet, from your point of view, the future remains unknown. Not because it doesn't exist, but because you haven't reached it. Uncertainty is real, even in a deterministic system, because you don't have access to the total map. This balance between determinism and experience may be the key to understanding time not as a physical force, but as a perceptual veil. A veil that lets you live out your story moment by moment, without seeing the whole book at once. So what is time? It may be the structure of awareness itself, not something you observe, but something you generate, not a river you ride, but a lens you look through. And if that's true, then time might not be a thing at all. It might be a way of seeing, a mode of consciousness that allows you to witness change, remember the past, and imagine a future. Time might be the syntax of reality, the grammar that gives your life meaning and continuity. Without it, the world would not disappear, but it would become silent, unshaped, undecidable. And so, time remains both the most familiar and the most mysterious element of your existence. What if time doesn't exist at the fundamental level of reality, but rather arises from something deeper, something even more mysterious? That's the idea behind timeless quantum cosmology and emergent time theories. In these views, the laws of physics don't evolve in time. Instead, time is a side effect, a shadow of more fundamental relationships. Let's go back to quantum mechanics. In the quantum world, particles don't have definite positions or velocities until they're measured. They exist in a blur of probabilities, called a wave function. That wave function doesn't evolve in time the way objects move in classical physics. Instead, it evolves according to the Schrödinger equation, which is itself time reversible. But here's the twist. The evolution described by quantum mechanics isn't a smooth unfolding in time. It's a change in probabilities. It's about shifting expectations. And those expectations don't imply a present moment that moves. They describe relationships between different possibilities. Now add gravity to the picture. When you try to describe the entire universe using quantum mechanics and general relativity, time disappears entirely. You end up with something like the Wheeler-DeWitt equation again. Static, timeless, frozen. The universe doesn't change. Only your perception does. So what creates the illusion of change? According to Carlo Rovelli and other researchers working on loop quantum gravity, time may be nothing more than a measure of change in the relations between events. There is no absolute now. There's just a complex web of interactions, shifting and flowing relative to each other. From that shifting network, time arises. It's like temperature. A single particle doesn't have a temperature. Temperature only makes sense when you consider a large number of particles and their interactions. In the same way, time may only exist in a statistical sense when you zoom out from the fundamental level and look at the big picture. This is the idea of emergent time. It says that time is not fundamental. It's a macroscopic effect, like pressure or heat. And like those concepts, it can break down at small scales or extreme conditions, such as at the moment of the Big Bang or inside a black hole. Inside a black hole, time behaves strangely. To an outside observer, time appears to slow down near the event horizon, the boundary beyond which nothing can escape. To someone falling in, time seems to continue as usual, but the outside universe appears to accelerate. From the outside, it takes forever for someone to fall in. From the inside, it happens quickly. This breakdown of agreement about time shows that it's not universal. Time depends on your location, your speed, your gravity field. It's not the same for everyone. It's not absolute. It bends, stretches, and warps. That idea, introduced by Einstein, reshaped physics. In general relativity, time is part of spacetime, a dynamic fabric that curves in response to mass and energy. A clock on a mountain ticks faster than a clock at sea level. A clock on a spaceship ticks slower than one on Earth. These aren't theories. They're measured, tested, and used in GPS satellites every day. But even Einstein's theory doesn't explain why time feels like it flows. It just tells us that the rate of flow depends on context. So why does time seem to move in one direction, always forward? This brings us back to entropy. Entropy isn't just a physical concept, it's also a deeply psychological one. Every moment of your life, you are gathering new memories, increasing the complexity of your neural patterns, making decisions that lock in certain paths while excluding others. Each of these adds entropy. Each makes reversal harder. This is why time feels like it flows. Not because anything is actually flowing, but because the universe is moving from a less probable state to a more probable one. You are part of that movement. Your thoughts, your memories, your story. They are entropy-driven structures. In this view, time is just another word for change. And change is just the unfolding of increasing complexity. You never step into the same moment twice because the configuration of the universe is never exactly the same. But does this mean the past and future are illusions? Some philosophers say yes, others say no. They're just different locations in a landscape you can't see all at once. Think about a DVD. All the scenes in a movie exist on the disc at the same time, but when you watch it, the story unfolds moment by moment. Your player selects a sequence of images. If you rewind, you can go back. If you fast forward, you can skip ahead. But the whole film is already there. In a block universe, you are like that DVD player. Your consciousness reads one frame after another, creating the illusion of movement. But all the frames exist: past, present, and future. So then, what is the now? Neurologically, the present moment is a tiny window of sensory integration, just a few seconds wide. Your brain blends sounds, sights, and sensations that arrive at slightly different times and creates a unified experience. It's a construction, not a feature of reality. Your sense of the now is stitched together by the brain's timing mechanisms. It's incredibly precise, yet it's also subjective. Drugs, emotions, age, trauma, all can alter your perception of time. Boredom stretches it, fear freezes it, joy compresses it. Time is elastic inside the mind. If your mind can change time, is time inside your mind. That's not just poetic, it's supported by science. Studies show that patients with certain types of brain injuries lose their sense of temporal order. They remember events but can't tell what happened first. Others lose the ability to anticipate or plan, becoming trapped in an eternal now. That means your experience of time is not just physical, it's cognitive. It's the product of memory, attention, prediction, and awareness, and it's fragile. Now consider a radical idea from theoretical physics. Time might be an emergent property of quantum entanglement. In this model, called the Page-Wouters mechanism, the universe doesn't evolve in time. It exists as a static quantum state. But if you split the universe into two parts, one part to act as a clock and one part to act as the system being measured, you can get the appearance of time. From the inside, it looks like things are changing. From the outside, nothing is. This is sometimes called time without time. Change arises from the entanglement between parts of the system. If that sounds bizarre, that's because it is, but it's also consistent with quantum theory. This could mean that your entire experience of time is built from relationships. The clock is only meaningful relative to what it's measuring. Your sense of before and after is built from entangled interactions. Without those, time would disappear. This relational view changes everything. It means there is no universal timeline, no master clock, no cosmic stopwatch ticking somewhere in the void. There are only interactions, complex, beautiful, and dynamic. From that, time arises. This view echoes ancient philosophies like those of the Greek philosopher Heraclitus, who said, "You cannot step into the same river twice. Everything flows, but what flows may not be time itself. It may be the relationships between things. The universe in motion, the dance of complexity. You are part of that dance. Your memories, your hopes, your story. They are threads in the web of change. They don't float through time. They create time. Every heartbeat, every breath, every thought adds to the structure of now. And when you sleep, your brain replays those threads. It compresses, reorganizes, and integrates. Sleep is when your mind edits the movie of your life, assembling meaning from chaos. You might think of sleep as stepping out of time, briefly, to clean the lens through which you see it. So what, then, is the ultimate nature of time? No one knows. That's the honest answer. Time is one of the most deeply mysterious aspects of the universe. It may not even be a thing at all. It may be the result of something more fundamental, something we don't yet understand, something we may never be able to see directly. But one thing is clear: time is not what it seems. It is not a river. It is not a clock. It is not a line stretching from past to future. It is a structure you inhabit, a framework of experience, a language of change, and that is enough to make it real, at least for you. Because in the end, whether or not time exists at the deepest level, your life unfolds within it. Your moments matter, your memories matter, your choices matter. Let's now dive into one of the most fascinating and unresolved mysteries in physics: the arrow of time. Why does time move forward and not backward? Why can you remember the past but not the future? Why does a broken glass not reassemble itself? To understand the arrow of time, you have to confront a paradox. The fundamental laws of physics, the equations that govern everything from atoms to galaxies, are time-symmetric. That means they work the same forward and backward. If you watch two particles collide and then play the video in reverse, the laws don't care. Both directions are allowed. So why in your everyday life does time seem to have a direction? The answer, once again, involves entropy. Entropy gives time a direction because it tells us which states are more probable. The second law of thermodynamics states that in a closed system, entropy tends to increase. That's not a law of motion, it's a law of statistics. There are more disordered states than ordered ones, so over time, systems naturally drift toward disorder. But here's the deep question. If the laws of physics are symmetric, why did the universe start in such a low entropy, highly ordered state? That's the real puzzle. Because if the universe began in a random, high entropy state, there would be no arrow of time. Everything would be smeared out. No stars, no life, no structure. But the early universe was shockingly smooth, almost perfectly uniform, extremely low in entropy. This strange low entropy beginning is what allows time to appear to move forward. It gives everything direction. Stars form, planets cool, beings evolve, civilizations rise. All because of that original imbalance. So what caused it? Some physicists suggest that the Big Bang wasn't the beginning of everything, but just one moment in a larger cosmic structure. Others propose that entropy is linked to the shape of space itself, that the universe is expanding, and this expansion allows for more possible states, meaning entropy can grow. There are also theories involving multiverses, in which each universe starts with its own unique conditions. Perhaps we just happen to live in a universe with a strong time arrow, because only such a universe could support complex observers like you. But we don't know. The reason time flows one way remains one of the biggest open questions in cosmology. Still, even if you don't know why the arrow exists, you can explore how it shapes experience. In your own life, the arrow of time defines memory. You remember what already happened, not what will happen. And that's not just biological, it's physical. Memory itself is a low entropy structure. To form a memory, your brain must store information in a stable way. That means energy must be used to create order. The act of remembering is irreversible. You can't unburn a match. You can't unform a memory. This asymmetry links your personal experience to the deep structure of the cosmos. It also defines causality, the idea that events cause other events in a consistent order. You light a match, then the flame appears. You speak, then sound reaches someone else's ears. Cause, then effect. That pattern is only possible because time has a direction. But does causality ever break down? In some quantum experiments, the answer seems to be yes. Take the famous delayed choice quantum eraser experiment. In this setup, particles are fired toward a detector in such a way that future measurements appear to determine past behavior. Depending on whether or not a detector is active after a particle has passed through a slit, the particle seems to decide how it behaved before the measurement. This doesn't allow you to send information into the past, but it blurs the line between cause and effect. In the quantum world, the order of events can become fuzzy. Sometimes it's not clear what came first. That fuzziness has led some researchers to propose models of physics in which time is not a strict sequence of before and after, but more like a network of conditional relationships. Instead of a single timeline, there's a web of interdependencies. In this view, causality is not a chain, but a tapestry. And you, as an observer, weave your own thread through it. That may sound abstract, but it has implications for how you think about free will. If time is a fixed sequence, and everything is determined by initial conditions, then in a sense, your future is already written. Your choices are illusions, just moments unfolding along a predetermined path. But if time is flexible, if causality is emergent, if observation plays a role in shaping outcomes, then the story isn't set. Your decisions matter. Your awareness shapes the future. This isn't wishful thinking. It aligns with some interpretations of quantum mechanics, like the participatory universe model, which suggests the universe requires observation to manifest outcomes. In these models, consciousness isn't outside time. It's part of the mechanism by which time unfolds. And that returns us to the question, is time something that exists independently, or is it created through interaction? Let's look at time in mathematics. When physicists model the universe, time usually appears as a parameter, like a label on a sequence of events. But in some theories, you can remove time entirely and still have a valid description of the system. These are called background-independent theories. One of the most radical versions of this is Julian Barbour's timeless physics. He argues that time doesn't exist at all. What we call time is just a series of snapshots, static arrangements of the universe, which he calls nows. Imagine a cosmic photo album with every possible configuration of the universe. Each page is a moment. There's no need to flip the pages in order. The order is imposed by your consciousness. You remember the previous pages. You anticipate the next. But all the pages already exist. In Barbour's view, motion is an illusion. Change is a trick of memory. There is no past or future, only a collection of nows. This sounds strange, but it helps resolve paradoxes in quantum gravity and cosmology. And it mirrors ideas from mysticism and philosophy, that time is a construction of the mind, not an intrinsic part of nature. If true, it means your life is not a journey through time, it's a set of configurations. And what gives it meaning is not time itself, but the awareness that connects those configurations into a story. Your story. This brings us to the idea of time as narrative. Human beings are natural storytellers. You impose sequences on events. You look for causes, consequences, turning points, resolutions. You define your identity through memory and expectation. You think of your life as a timeline with a beginning, a middle, and an end. But this timeline isn't a feature of physics. It's a framework created by your brain to make sense of experience. That's not a weakness, it's a strength. It allows you to plan, to hope, to learn. It allows you to feel meaning. The neuroscientist Daniel Dennett calls this the narrative self. You are not a static object moving through time. You are a process, a story being told in real time by your brain. The continuity you feel is not because time flows, but because your story does. And this story is deeply tied to memory. Without memory, there is no past. Without imagination, there is no future. Both are acts of construction. Your brain doesn't replay perfect recordings. It rebuilds the past every time you remember it. It simulates the future every time you plan. Time, in your experience, is a work of fiction, crafted moment by moment. And yet, it feels real. That feeling is powerful. It's rooted in emotion, in sensation, in attention. You feel time when you wait, when you anticipate, when you regret, when you long. Time is not something you watch from the outside, it's something you feel from within. This subjective time is deeply human. It's why time flies when you're engaged and drags when you're bored. It's why memories can seem close or far, regardless of how long ago they happened. In this internal landscape, time doesn't tick, it pulses, it contracts and expands, it flows and fractures, and sometimes it disappears. Consider moments of deep flow, when you're so immersed in an activity that time seems to vanish, or moments of trauma, when seconds stretch into eternities. These aren't anomalies, they're windows into how elastic time truly is. Now take it one step further. Imagine a moment so complete that it contains everything. A moment without before or after. A moment that is all moments. This is the kind of moment mystics and meditators sometimes describe. A timeless present. A state beyond time. Is this a psychological state, or a glimpse into something deeper? Could time itself be an illusion created by the limits of perception? Could the true nature of reality be timeless, and only appear sequential because of how your mind processes it? You don't need to answer that. You only need to wonder. Wonder is where science and experience meet. It's what drives both physics and philosophy. It's what allows you to ask, not just how time works, but what it means. Time may be emergent, it may be relational, it may be an illusion. Let's now explore the possibility that time isn't a singular, universal feature of the cosmos, but a local phenomenon, something that can vary depending on where you are and how you're moving. This might sound strange, but it's a direct consequence of Einstein's theory of relativity. To truly understand what time is, you have to abandon the idea that it ticks the same for everyone. In Newtonian physics, time was absolute. There was one clock ticking behind the scenes of the universe, the same for all observers, no matter where they were or what they were doing. Time was a universal stage on which events played out. But Einstein showed this was wrong. According to the theory of special relativity, time is relative. The faster you move through space, the slower time moves for you. This isn't just a philosophical idea, it's a measurable effect called time dilation. If you could travel near the speed of light, hours might pass for you, while years pass for someone staying behind. And this has been confirmed through experiments with fast-moving particles and precise atomic clocks flown on airplanes. It's real. This means that time is not a constant flow. It bends, it stretches, it depends on velocity. Now add gravity into the mix. Einstein's general theory of relativity expanded these ideas to include acceleration and gravity. In this model, gravity isn't a force pulling objects toward each other, it's a curvature of space-time itself. Massive objects like planets and stars warp the fabric of space-time, and time slows down near them. This too has been tested. GPS satellites orbit Earth in a weaker gravitational field than you experience on the surface, so time ticks slightly faster for them. Engineers have to correct for this, or the GPS system would quickly become inaccurate. What does this mean for your understanding of time? It means that time is not one thing, it's many. Each observer carries their own clock. Each location in the universe has its own rate of time. Time is not like a river flowing the same speed everywhere. It's more like a landscape with hills and valleys. Time flows faster in some places, slower in others. And in the most extreme places, time can nearly stop. Near the event horizon of a black hole, time slows dramatically. To a distant observer, an object falling into the black hole appears to freeze at the edge. Light from it becomes redder and dimmer. The passage of time, from that external point of view, halts. But for the object falling in, time continues as usual. There's no feeling of slowing, no sensation of stopping. just the relentless personal ticking of a local clock until it reaches the singularity. This contradiction is hard to grasp, but it reveals something profound. Time is not a universal feature. It is a relationship. There is no such thing as now in the universe. There is only your now. This leads to the concept of spacetime. Instead of thinking of time and space as separate entities, Einstein unified them into a single, four-dimensional fabric. You live in spacetime, not space, and then time. Your position in time is just as real as your position in space. You can move through space in different directions. You can walk forward, backward, left, right, but your motion through time seems constrained. You can only go forward. Yet the laws of space-time don't insist on that direction. They allow time to be treated like a dimension, one you happen to experience in a linear way. But is that just perception? In the space-time view, the past, present, and future are all equally real. They are laid out in the fabric, like all locations on a map. You don't think of Paris and Tokyo as more or less real because you're not currently there. In the same way, the past and future don't cease to exist just because you are here now. This idea is sometimes called the block universe. In the block universe model, all of time exists at once. Every moment, every heartbeat, every sunrise, every word you've spoken is still there, fixed in the four-dimensional structure. You are a being stretched across time, like a thread running through a tapestry. This doesn't mean your choices aren't real. It just means they already exist in the structure of space-time. The future isn't being created as you move forward. It's already there. You are unfolding it by moving along your path. This challenges your intuition, but it also offers something strange and beautiful. The idea that nothing is truly lost. That every moment still exists somewhere in the fabric. That you're not just racing toward death, but inhabiting a structure that includes every moment of your life forever. This view aligns with the equations of relativity, but not necessarily with your experience. You still feel time passing. You still experience becoming. You still anticipate, remember, grieve, hope. So what causes that feeling? That's where thermodynamics, again, plays a role. The arrow of time comes from the increase of entropy, but your awareness of time, your sense of flow, emerges from consciousness. Neuroscience has shown that your brain doesn't measure time like a stopwatch. It estimates time based on changes in perception, memory, and attention. If nothing is happening, time seems to slow down. If everything is happening at once, time rushes by. You are the storyteller of time. Your mind weaves a continuous narrative from flickering sensations. It organizes events into sequences. It bridges the gaps. It filters the chaos of experience into a smooth stream. But sometimes the stream breaks. In extreme conditions, like trauma, deep meditation, or psychedelic states, your sense of time can dissolve. Minutes stretch into eternities. Hours vanish in an instant. This shows how fragile and constructed your sense of time really is. It also shows that time, as you experience it, is not just physics. It's biology, it's psychology, it's culture.
Different cultures have different relationships with time. Some view it as linear, past, present, future. Others see it as circular, with cycles of death and rebirth, seasons, reincarnations.
Some cultures prioritize punctuality, measuring life in precise segments. Others flow with time, letting the moment expand or contract. These are not just habits, they're worldviews. They shape how people experience life, relationships, and even identity. So time is not only physical, it's personal. And now let's go even deeper. What if time is not just personal, but participatory? Some interpretations of quantum mechanics suggest that observation affects reality, not just what you see, but what exists. In this view, time is not a container, it's an interaction. This is the essence of the relational view of time. In relational physics, time is not a background that events move through. It's a result of relationships between changing systems. Clocks don't measure a universal flow. They compare changes between one system and another. For example, if you and a distant galaxy both experience change, you can compare those changes and define a time interval. But if nothing changes, if no events occur, then time has no meaning. It's not ticking, it's simply undefined. This idea echoes ancient philosophy. Heraclitus said, "All is change." The idea that time is change, not a container, but a measure of transformation, has been present in human thought for millennia. Modern physics is circling back to this view. In quantum gravity, models like loop quantum gravity and causal set theory, spacetime may not be continuous. It may be made of discrete events, tiny, indivisible moments of interaction. Time, in this view, emerges from the pattern of these events. It is not a backdrop, it is a structure built by connection. This is radical. It means that without interaction, there is no time. Without you observing, connecting, measuring, there is no flow, no sequence, no becoming. You, the observer, are not separate from time. You are a participant in its creation. And this makes time not just a dimension, but a dialogue. A dialogue between matter and motion, between space and awareness, between the universe and you. So where does this leave you? It leaves you in a world where time is not what it seems. Not a ticking clock, not a rigid ruler, not a fixed line. Time is elastic, relational, emergent. It bends near gravity, it slows at high speeds, it vanishes in deep focus, it stretches in longing, it loops in memory, it dances at the edge of black holes, it flickers in quantum experiments, it fractures in dreams, and through it all you move, not as a passive traveller, but as a creator of meaning. Because time is not just what happens, it's what you make of what happens. It's not just motion, it's memory. It's not just sequence, it's story. Your story.
The question, what is time really, might never have one answer, because time is many things: physical, psychological, cultural, cosmic.
It's the beat of a heart, the rhythm of a planet, the swirl of galaxies, the gap between thoughts, the whisper of becoming. And maybe, just maybe, it's not something you pass through, but something you build. With every choice, every breath, every act of attention, you shape time. You bend its flow by living. And in doing so, you answer the question not with a theory, but with a life.